time for one of my trademark super quick homework hints. So this is problem 2341, where you have a large sheet of charge, positive charge, and then you have a small ball of positive charge, and it's connected by a string, and we're told that it's at rest at some angle, like so, from the vertical sheet of charge, right? So this is one of those problems where I say don't forget everything that we talked about last semester, right? So if it's at rest, that means that the sum as a vector of all the forces is equal to 0, right? So we need to see what forces are acting on it, and then figure out what we want to know is what is this charge density sigma over here, right? So what are the forces acting on it? Well, I hope you say gravity, right? mg, and that always points down. Then we've got some tension that's pointing in this direction. And then we have some electric force of repulsion from the positive sheet on the positive ball. So I'll call that F sub E, right? That's the electric force, which is going to be equal to the electric field times the charge of the ball. Okay, so this electric field you can find using, that's the electric field due to the source, which is the large sheet of charge, right? So that's something that you find using Gauss's law for a large sheet of charge. And then mg is something that we know we're given the mass of the ball. So now we need to look at, okay, all these vectors add up to 0. So the thing that you should always do is, when you're adding vectors, is break them into components. We can easily use our standard x and y axes for this, right? So you're going to have a y component of the tension and an x component of the tension, right? So we know that in the x direction, you're going to have Fe minus Tx is equal to 0, and in the y direction, taking up to be positive, you're going to have Ty minus Mg is equal to 0. So you might say, why do we care about what the tension is? And my answer is we don't, right? But we need to use that as maybe an intermediate step to find out what this electric field is, or what the electric force is, right? So now we have two equations with two unknowns. So we don't know the tension, but we don't care about it. What we're trying to solve for is this electric field, right? So you got to do some trigonometry to break the tension into its x and y components, and then so the part that really relates to what we've done in this chapter is calculating this electric field for the sheet of charge, and then referring back to previous chapters that the force is equal to the electric field times the charge on the ball.